Imagine the scorching desert sun, endless sands, and suddenly, amidst millennia of layers, archaeologists find something that makes their hearts stop. Not just an artifact, but a mystery that challenges our understanding of history. It was an astrolabe, an ancient instrument covered in the dust of ages, but preserving astonishing engravings on its surface. From the very first glance, it became clear they had something unique before them. Ordinary astrolabes showed familiar constellations, but this one pointed to stars that weren't there. Not in the modern night sky. It was a shock. How was this possible? Had the ancient masters made a mistake? Or did this instrument hold a secret, much deeper than one could imagine? This discovery immediately raised many questions. What kind of stars are these? Where did they come from on an ancient mechanism? And, most importantly, what message does this artifact from the distant past carry for us? This is just the beginning of an amazing story that will unveil unexpected facets of cosmic mysteries and, perhaps, even change our perception of Earth. After that shocking discovery, which forced us to reconsider our usual notions of the starry sky, it's time to delve into the history of astrolabes themselves. To understand the uniqueness of Alexander's artifact, one must first understand what this instrument is and what role it played in the ancient world. An astrolabe is not just a beautiful mechanism, it is a true ancient computer, capable of solving complex astronomical problems. Its history begins long before the first written mentions, but its heyday occurred during the golden age of Greek science. Imagine how, even before our era, the great Greek astronomer Hipparchus, who lived in the 2nd century BC, was already laying the groundwork for the creation of such instruments. Although his works on the astrolabe have not survived, it is believed that he was the first to develop the method of stereographic projection, which became the cornerstone for all subsequent astrolabes. This was a revolutionary step, to transfer the three-dimensional sky onto a two-dimensional plane, while preserving all angular relationships. Brilliant, isn't it? The first true astrolabes that have come down to us date back to approximately the 5th century AD, but their design clearly indicates a long evolution. These instruments were true masterpieces of art and engineering. They consisted of several main parts. The mater, a circular disc on which latitudes and longitudes, as well as zodiacal signs, were engraved. Tympans, interchangeable plates, each corresponding to a specific geographical latitude and containing a grid of coordinates. And the rete, an open-work plate with pointers to stars and constellations. All these elements rotated relative to each other, allowing for the modeling of the movement of the celestial sphere at any given time and at any point on Earth. It was simply incredible for that time. The significance of astrolabes for the ancient world is hard to overestimate. They were indispensable for astronomers, helping them predict the movement of planets, determine the time of rising and setting of stars, and calculate the dates of eclipses. But their application was not limited to astronomy alone. Sailors used them for navigation, determining latitude by the height of the sun or the North Star. This was a breakthrough that allowed them to more confidently traverse the boundless expanses of the seas and oceans. Imagine an ancient traveler who, looking at the stars, could accurately know where he was and where he needed to sail. Astrolabes were also used to tell time day and night, to measure the height of buildings, and even to cast horoscopes, which at that time was considered an important part of science and philosophy. The true flourishing of astrolabes occurred during the Hellenistic period and then continued in the Islamic world, where their design was significantly improved. But it was the works of the great Claudius Ptolemy who lived in the 2nd century AD, that established the theoretical foundations for their use. In his fundamental work, he described in detail the principles of the celestial sphere and the calculation methods that underpinned the art of astrolabes. His geocentric model of the world, though it proved to be erroneous, was so accurate for its time that it allowed astrolabes to serve faithfully for over 1,400 years. These instruments were not just tools. They were a symbol of humanity's striving for knowledge, for understanding the universe. They opened the way to new discoveries, to the expansion of the boundaries of the known world, and perhaps even to those stars that we do not see today. Now that we've somewhat grasped what an astrolabe is and what role it played in the ancient world, it's time to return to our enigmatic artifact. Who could have owned this instrument, which shows stars that aren't there? And here, one of history's most legendary figures steps onto the stage: Alexander the Great. His name is inextricably linked with grand conquests, but few know how deep his interest in science, and astronomy in particular, truly was. For Alexander was not merely a military leader, he was a pupil of Aristotle himself, the greatest mind of antiquity. Aristotle instilled in the young king not only a love for philosophy and rhetoric, but also a passion for understanding the world, for systematizing it. Historical sources are replete with mentions of how Alexander took scholars, cartographers, and engineers with him on his campaigns. He didn't just conquer lands, he studied them, described them, and mapped them. And of course, the sky above these lands could not escape his attention. There is abundant, albeit indirect, evidence that Alexander showed keen interest in celestial phenomena. He consulted with astrologers and soothsayers, which was common practice for rulers of that era, but his curiosity extended beyond a superstitious fear of celestial signs. He sought to understand them, to comprehend them. It is not impossible that complex astronomical instruments could have been created or used within his entourage. So, could our astrolabe have belonged to him? On the one hand, there is no direct documentary evidence that this specific astrolabe was in Alexander's hands. We don't find records in ancient chronicles like. However, there are a number of circumstantial clues that make us seriously consider this version. Firstly, there's the discovery location. The astrolabe was found in a region that was once part of Alexander's vast empire. His troops passed through these lands, leaving behind not only destruction, but also a cultural legacy. Secondly, there's the technological complexity of the instrument. As we've already mentioned, Alexander's astrolabe is striking in its precision and intricate craftsmanship. Its creation required not only deep astronomical knowledge, but also highly developed engineering skills, as well as access to rare metals and mastery of their processing. In the era of Alexander the Great, thanks to his patronage of the sciences, such conditions could well have been created. After all, he spared no expense on research and technological development. And finally, the most intriguing aspect: the anomalous constellations. If the astrolabe truly shows the sky of another era, then this could have had colossal significance for Alexander. Perhaps he or his scholars encountered a phenomenon that did not fit into existing understandings of the world. And a man like Alexander always sought to unravel mysteries, to understand the incomprehensible. Imagine the scene: the great commander stopping for a rest somewhere in Mesopotamia or Persia, bending over a gleaming metal disc. He isn't just looking at the stars, he's trying to discern something more than just celestial bodies. He's searching for answers to questions that could change his understanding of the universe. Perhaps the astrolabe was not just a tool, but a key to ancient knowledge that Alexander sought to acquire. After all, he was known for his desire to unite cultures, to seek universal truths. He believed in his divine mission, and perhaps this instrument was for him a kind of confirmation of his special connection to the cosmos. Scholars studying this artifact do not rule out that it could have been custom-made for Alexander or for his inner circle. After all, his retinue included outstanding minds of the time, capable not only of appreciating such an instrument but also, perhaps, of participating in its creation. The version of the astrolabe belonging to Alexander the Great remains a hypothesis, but it possesses a powerful allure. It adds another layer of mystery to the image of the great commander and forces us to look at his era in a new light. If this is indeed his astrolabe, then it becomes not just a historical artifact, but a bridge between two eras, between a legendary figure and an inexplicable mystery that still challenges us. Now that we're closer to unraveling the identity of the possible owner, it's high time we looked inside the astrolabe itself, for it is its material embodiment, its physical characteristics, that can reveal even more secrets to us. Let's imagine ourselves in the shoes of scientists who have just gained access to this incredible artifact for the first time. They don't just look at an ancient object, they see in it a message from a distant past, encrypted in metal and engraving. The first thing that catches the eye is the material. Alexander's astrolabe is made of an astonishingly pure alloy, which at first glance resembles brass, but upon closer inspection turns out to be much more complex. Modern spectral analyses have shown that it's not just copper and zinc. Traces of other metals are present in the alloy, and in proportions that seem impossible for ancient metallurgy. Metallurgical scientists were astounded. They discovered microscopic inclusions of rare elements, which significantly increase the strength and corrosion resistance of the material. How could ancient masters have achieved such a level of purity and such complex alloys? This still remains a mystery. Perhaps they possessed some lost technologies or used mineral sources unknown to us. This material, it seems, was created specifically for durability, to withstand the test of millennia and preserve its message for future generations. The engraving deserves special attention. The entire surface of the astrolabe is covered with the finest lines, depicting stars, constellations, as well as certain symbols that are not yet amenable to unambiguous deciphering. The engraver's skill is astonishing. The lines are so thin and precise that it seems as if they were applied using modern laser technologies, and not primitive tools. Under a microscope, it is visible that the edges of the engravings are perfectly even, without the slightest burrs or irregularities. This speaks to the incredible precision and hardness of the tools with which the ancient masters worked. How could they achieve such filigree work without optical instruments, without modern cutters? Some symbols and images have no apologues in ancient cultures known to us. They do not resemble Egyptian hieroglyphs, Mesopotamian cuneiform, or Greek script. This is a complex, almost alien language, which may contain the key to understanding the astrolabe's purpose. Perhaps these are not just decorative elements, but part of a code that needs to be deciphered. But the most amazing thing, of course, is the mechanism itself. Alexander's astrolabe is not static. It is a complex system of movable discs, gears, and pointers. Its internal structure is striking in its complexity. Unlike the astrolabes known to us, where the main elements rotate manually, this instrument contains something that resembles a clockwork mechanism. Scientists have discovered microscopic gears connected to each other in such a way as to ensure the synchronous movement of several parts. This is not just a demonstration tool, it is a working model of the celestial sphere, capable of tracking the movement of stars and planets with incredible accuracy. Specialists in ancient mechanics were delighted and at the same time perplexed. Similar mechanisms, known as Antikythera mechanisms, appeared much later. How could such a complex system have been created in the era of Alexander? This calls into question many of our ideas about the development of technology in the ancient world. The mechanism is so complex that its creation required the deepest knowledge in mathematics, astronomy, and engineering. It could not have been the result of a random invention. It is the fruit of centuries of development and accumulation of knowledge. Every gear, every lever is made with incredible precision, which excludes the possibility of crude manual labor. This is not just craftsmanship, it is genius ahead of its time. Some researchers even put forward a bold hypothesis. Perhaps this mechanism was created not to show the current position of the stars, but to model past or future celestial events. After all, if the astrolabe shows stars that are not there, then perhaps its mechanism is designed to calculate temporal cycles, to predict global changes in the sky. This technological uniqueness of Alexander's astrolabe, its perfect material, mysterious engraving, but incredibly complex mechanism, is not just an artifact. It is a challenge to our understanding of history, technology, and perhaps even the very nature of time. This instrument, it seems, was created to keep a secret, and perhaps it is time to reveal it. After we have examined the incredible technological complexity and mysterious materials of Alexander's astrolabe, it is time to look at the most intriguing aspect: the star-studded sky captured on this artifact. It is here that the real anomalies begin, leaving scientists scratching their heads. When astronomers first compared the engravings on the astrolabe with modern star charts, they encountered shocking discrepancies. Some constellations that we see today were displaced relative to their usual positions. Others, on the contrary, appeared significantly brighter, or conversely, dimmer than they should have been in that era. But most importantly, the astrolabe had engraved stars and entire constellations that simply do not exist in the modern night sky. They vanished, as if they had never existed. This was not just a small deviation, but a fundamental difference that could not be explained by ordinary astronomical phenomena. The first attempts to explain these discrepancies were quite logical. Perhaps the ancient craftsmen made mistakes during engraving. After all, even the most skilled artisans could err. But the more scientists studied the astrolabe, the less plausible this version seemed. The precision of the engraving, which we discussed earlier, was so high that the probability of accidental errors was minimized. Every line, every dot was applied with astonishing accuracy. Moreover, errors usually tend to be chaotic, but here there was a certain systematicity in these discrepancies. Another hypothesis was that the creator of the astrolabe deliberately distorted the image of the starry sky. Perhaps this was done for some mystical or ritual purposes, to hide true knowledge from the uninitiated. In the ancient world, astronomy was often intertwined with astrology and esotericism, and such an explanation had a right to exist. But why? What was the purpose of such a large-scale deception or symbolism? If it was a deliberate distortion, it must have served some very important purpose. But for now, that purpose remains hidden. Astronomers began conducting detailed comparisons using advanced computer modeling techniques. They superimposed the astrolabe's map onto star atlases from various eras, trying to find some kind of match. But the deeper they delved into this data, the more questions arose. The stars absent from the modern sky were not random faint objects. Some of them were bright and significant enough to be noticed and catalogued. Their complete absence in our modern observations was inexplicable. One of the first examples of such an anomaly was the absence on the astrolabe of some stars belonging to the constellation Orion, which, according to our data, should have been visible in that era. And conversely, stars appeared that should not have been there. This created a paradox. It was as if someone had taken a modern map of the starry sky and altered it, adding and removing some elements. Attempts to explain these anomalies using known astronomical phenomena, such as proper star motion, also did not provide a complete answer. Although stars do move across the sky, their movements over several thousand years cannot lead to such radical changes in the arrangement of entire constellations or to the complete disappearance of bright objects. This required something much larger. The question arose before scientists: if this is not an error and not a deliberate distortion in the usual sense, then what is it? Could the astrolabe be a map of heavens that we simply do not know? Perhaps it reflects the starry sky in some other, unknown to us, era, or even in another dimension? These questions seemed fantastic, but the facts were undeniable. This ancient instrument held a secret that challenged all our notions about space and history. Alexander's astrolabe did not just show stars. It showed stars that do not exist, and this was only the beginning of its amazing revelations. Now that we've grasped the scale of the anomalies on Alexander's astrolabe, it's time to delve into the very heart of this enigma: the vanished constellations. These aren't just a few missing stars, these are entire patterns in the celestial sphere that seemingly should have been there, but are not. It's as if someone tore pages from an ancient book, leaving only hints of what was once written. Scientists, armed with the most modern telescopes and computer models, began the painstaking work of cataloging these phantom constellations. They compared the engravings on the astrolabe with thousands of ancient star catalogs, from Babylonian clay tablets to Egyptian temple frescoes, from Chinese astronomical records to Persian manuscripts. And the results were astounding. It turned out that the astrolabe features several clearly defined star groups that are entirely absent from the modern atlas of the sky. One such group, provisionally named "Zero," quests 7 bright stars located in the area of the modern constellation Ophiuchus. According to our current data, there is not a single object in this region that could correspond to such a description. Not a single star capable of forming such a clear and recognizable pattern. The intensity of these stars' luminosity on the astrolabe indicates that they were bright enough to be visible to the naked eye. Why are they not there now? Another, no less mysterious constellation, provisionally named the Hero's Chariot, was discovered in the region of the modern constellation Hercules. It consisted of 12 stars, combined into a complex configuration resembling an ancient war chariot. And again, not a single hint of these stars in modern catalogs. These are not faint, barely discernible points, but quite distinct objects that, judging by the engraving, had significant brightness. The search for mentions of these phantom constellations in historical texts proved to be no less captivating. Surprisingly, some hints were indeed found. In ancient Sumerian texts, dating back to the 3rd millennium BCE, descriptions of star patterns were discovered that strikingly resembled the Phoenix constellation. These texts spoke of a rising bird carrying fire on its wings, which could well be a poetic description of this star group. Moreover, in some Egyptian papyri, dated to approximately 2,500 years BCE, images of celestial maps were found that depicted star clusters similar to the Hero's Chariot. These images were stylized, but the general contours and number of stars matched so closely that it could not be a mere coincidence. These ancient mentions, scattered across different cultures and eras, create an incredible picture. They indicate that these constellations, which we do not see today, were once part of the night sky and were known to ancient civilizations. But how is this possible? If these constellations existed, then why did they disappear? And why does Alexander's Astrolabe, dating to a much later period, specifically show them? This catalog of vanished constellations is not just a list of missing objects. It's a challenge to our understanding of the stability of the celestial sphere, of the immutability of stars. It forces us to wonder, what if the sky we see today is just one of its many changing forms? What if Alexander's Astrolabe is a window into the past, showing us not just an ancient map, but evidence of grandiose cosmic events that changed the face of the night sky? Perhaps these are not just stars, but a message encrypted in celestial patterns waiting for its time to be deciphered. And every vanished light, every phantom star on this astrolabe is part of a large puzzle that we have yet to assemble. So, before us is a map of the sky, where there are stars that don't exist, and those that should be there are absent. This is not just a mistake or a fantasy of an ancient master. This is a challenge that requires a serious explanation. And the first, most obvious hypothesis that comes to astronomers' minds is the precession of the Earth's axis. It sounds complicated, but in reality, it's a well-known astronomical phenomenon that can explain a lot. What is precession? Imagine a spinning top. Its axis of rotation doesn't stand strictly vertically. It slowly traces a circle. Approximately the same thing happens with our Earth. Its axis of rotation, due to the gravitational influence of the Sun and Moon, slowly oscillates, describing a cone in space. A full cycle of such oscillation takes about 25,772 years, and this movement, though slow, has enormous significance for how we see the starry sky. Due to precession, the position of the celestial poles changes. If today Polaris is Alpha Ursae Minoris, then, for example, 4,800 years ago, during the construction of the Egyptian pyramids, Polaris was Thuban from the constellation Draco. And in 12,000 years, it will be the brightest Vega from Lyra. This means that over time, the coordinates of all other stars in the celestial sphere also change. They slowly, quote, zero relative to an earthly observer. Scientists immediately set to work on calculations. They began to model the position of stars in various historical epochs, based on known data about the speed of precession. The goal was simple: to find a point in time when the starry sky on Alexander's astrolabe would completely match what was actually there. This would be a breakthrough, explaining all the anomalies, and, to the surprise of many, the initial results were very promising. Modeling showed that some of the missing constellations marked on the astrolabe could indeed have been visible in certain ancient periods. For example, the constellation of Phoenix, which we discussed earlier, turned out to be a very real cluster of stars that was noticeable in the sky approximately 3,000 years BC. At that time, these stars had a different position relative to an earthly observer and formed a recognizable pattern. Similarly, the chariot of the hero could have been seen about 5,000 years ago. In that era, its stars were brighter and occupied positions such that they could easily be combined into this unique configuration. This was amazing. The precession hypothesis, it seemed, offered a key to the puzzle. However, the deeper scientists delved into these calculations, the more new questions arose. If precession explains the appearance of some phantom constellations, it does not explain the disappearance of others. Some stars that should have been visible in those ancient epochs were still absent from the astrolabe, and conversely, there were engravings on the instrument that did not fit into any of the known precession models. These were stars that, according to calculations, never formed such patterns or were too dim to be noticed. It turned out that precession explains only part of the enigma, but not all of it. It's like finding a puzzle piece that fits perfectly, but realizing that the other pieces still don't connect. Modeling showed that if one chooses an epoch in which some anomalies disappear, others immediately appear. There was no single point in time that would perfectly explain the entire star map of the astrolabe. For example, if we take the epoch of 3,000 years BC as a basis to explain the Phoenix, then other constellations that should have been on the astrolabe turn out to be displaced or absent. And if we try to adjust for 5,000 years BC to explain the chariot, then the Phoenix no longer matches. This created a paradoxical situation. The astrolabe seemed to show not one specific epoch, but a certain mixture of different times. This discrepancy made scientists wonder, does the astrolabe reflect not just a momentary position of stars in the past, but something more complex? Perhaps it is evidence not of one, but of several events, stretched over time? Or is it not precession at all, but something much grander, something that could fundamentally change the position of celestial bodies? The precession hypothesis, though it provided valuable clues, proved insufficient for a complete explanation of all the anomalies of Alexander's astrolabe. This meant that they had to search further, beyond the astronomical phenomena known to us. If the precession of the Earth's axis, this slow dance of our planet, cannot fully explain the mysteries of Alexander's astrolabe, then perhaps we should think bigger. What if the anomalies on the instrument point not just to slow astronomical changes, but to something much more radical? To something that fundamentally changed the Earth itself and its celestial picture. We are approaching one of the boldest and perhaps most frightening hypotheses: the theory of a different era of Earth, connected with a global cataclysm and a shift of the Earth's poles. This hypothesis suggests that in the distant past, our planet experienced a catastrophic event that led to the displacement of the Earth's axis. Imagine a planet that, like a giant top, received a powerful blow and changed the inclination of its axis of rotation, and with it, the position of the geographical poles. Such an event would not simply change the climate or landscape, it would turn the world upside down, both literally and figuratively. Such theories were long considered the domain of fringe science, but recent decades have brought amazing discoveries that force a re-evaluation of these views. If the Earth's axis did indeed shift, this would inevitably lead to a change in the visible starry sky for an observer from Earth. The constellations we see today would be in completely different positions, and those that were visible at one latitude could disappear beyond the horizon, or conversely, appear where they never were. This could explain not only the appearance of one constellations on the astrolabe, but also the anomalous arrangement of those that seem familiar. What geological and paleoclimatic data could support such a radical hypothesis? Scientists draw attention to many unexplained phenomena in Earth's history. For example, sudden and sharp climate changes in certain geological epochs. Fossil remains of tropical vegetation found in Arctic latitudes, or traces of glaciers in equatorial regions. All this indicates that Earth's climatic zones have not always been stable. One of the key pieces of evidence could be paleomagnetic studies. Magnetic minerals in ancient rocks record the position of Earth's magnetic poles at the moment of their formation. Analysis of this data shows that the geographical and magnetic poles of the Earth in the past did not coincide with their current position. Moreover, Some studies indicate rather rapid and significant shifts of the poles on geological timescales. For example, the phenomenon of so-called true polar wander suggests that the entire solid shell of the Earth, the lithosphere, can shift relative to the planet's axis of rotation. This is not just the slow movement of continents, but a larger and faster process, capable of changing the position of the poles by tens of degrees over a relatively short geological period. Modeling shows that such shifts could have been caused by colossal changes in the distribution of masses on the Earth's surface. For example, the formation or melting of huge ice sheets, or even gigantic volcanic eruptions. Another piece of evidence is the unexplained mass extinctions of species that occurred with enviable regularity. Many of these cannot be fully explained by asteroid impacts or ordinary climate changes. A sharp climate change caused by a pole shift could lead to such catastrophic consequences for the biosphere. Imagine, regions that were temperate suddenly find themselves in the polar zone, and eternal ice recedes, opening up new lands. This would be hell for some species and heaven for others, but in any case, a grand restructuring of the entire ecosystem of the planet. And we see traces of such restructuring in the geological record. The so-called megafauna paradoxes, findings of completely preserved mammoths and other large animals in the permafrost of Siberia and Alaska, can also be explained by a sharp climate change. These animals, judging by the contents of their stomachs, died instantly, overnight, freezing at very low temperatures, as if they had been put in a refrigerator. What could have caused such a rapid and widespread cooling in regions that were previously relatively warm? Perhaps Alexander's Astrolabe is not just a map of the starry sky of a past era, but an encrypted message about a global catastrophe. Some ancient people who survived a pole shift could have created this instrument to preserve the memory of the sky they saw before the catastrophe, or of the sky they observed in the short period after it, when the Earth had not yet stabilized in its new position. This would be a warning to future generations, a reminder of the fragility of our world and the possibility of sudden, radical changes. This hypothesis opens up completely new horizons for understanding the astrolabe. It transforms it from a simple SMS instrument into a chronographer, recording not only the passage of time, but also dramatic events in the history of the planet itself. And if so, then the stars on Alexander's astrolabe are not just vanished luminaries, but silent witnesses to a cosmic drama that unfolded on Earth. If the precession of the Earth's axis, this slow dance of our planet, cannot fully explain the mysteries of Alexander's astrolabe, then perhaps we should think bigger. What if the anomalies on the instrument point not just to slow astronomical changes, but to something much more radical? To something that fundamentally altered the Earth itself and its celestial landscape? We are approaching one of the boldest and perhaps most frightening hypotheses: the theory of a different era of Earth, connected with a global cataclysm and a shift in the Earth's poles. This hypothesis suggests that in the distant past, our planet experienced a catastrophic event that led to a displacement of the Earth's axis. Imagine a planet that, like a giant top, received a powerful blow and changed the tilt of its axis of rotation, and with it, the position of the geographical poles. Such an event would not simply change the climate or landscape, it would turn the world upside down, both literally and figuratively. For a long time, such theories were considered the domain of marginal science, but recent decades have brought astonishing discoveries that force us to reconsider these views. If the Earth's axis did indeed shift, this would inevitably lead to a change in the visible starry sky for an observer from Earth. The constellations we see today would be in completely different positions, and those that were visible at one latitude could disappear beyond the horizon, or, conversely, appear where they never were. This could explain not only the appearance of, quote, constellations on the astrolabe, but also the anomalous arrangement of those that seem familiar. What geological and paleoclimatic data could confirm such a radical hypothesis? Scientists point to many unexplained phenomena in Earth's history. For example, sudden and sharp climate changes in certain geological epochs, fossil remains of tropical vegetation found in Arctic latitudes, or traces of glaciers in equatorial regions. All this indicates that Earth's climatic zones have not always been stable. One of the key pieces of evidence could be paleomagnetic studies. Magnetic minerals in ancient rocks record the position of Earth's magnetic poles at the moment of their formation. Analysis of this data shows that the geographical and magnetic poles of the Earth in the past indeed did not coincide with their current position. Moreover, some studies indicate rather rapid and significant shifts of the poles on geological timescales. For example, the phenomenon of so-called true polar wander suggests that the entire solid shell of the Earth, the lithosphere, can shift relative to the planet's axis of rotation. This is not just the slow movement of continents, but a larger and faster process capable of changing the position of the poles by tens of degrees over a relatively short geological period. Modeling shows that the cause of such shifts could have been colossal changes in the distribution of masses on the Earth's surface. For example, the formation or melting of vast ice sheets, or even gigantic volcanic eruptions. Another piece of evidence is the unexplained mass extinctions of species that occurred with enviable regularity. Many of them cannot be fully explained by asteroid impacts or ordinary climate changes. A sharp change in climate caused by a pole shift could lead to such catastrophic consequences for the biosphere. Imagine, regions that were temperate suddenly find themselves in the polar zone, and eternal ice recedes, opening up new lands. This would be hell for some species and paradise for others, but in any case, a grandiose restructuring of the entire ecosystem of the planet. And we see traces of such restructuring in the geological record. The so-called megafauna paradoxes, finds of completely preserved mammoths and other large animals in the permafrost of Siberia and Alaska, can also be explained by a sharp climate change. These animals, judging by the contents of their stomachs, died instantly, overnight, freezing at very low temperatures as if they had fallen into a refrigerator. What could have caused such a rapid and widespread cooling in regions that were previously relatively warm? Perhaps Alexander's astrolabe is not just a map of the starry sky of a past era, but an encrypted message about a global catastrophe. Some ancient people who survived the pole shift could have created this instrument to preserve the memory of the sky they saw before the catastrophe, or of the sky they observed in the short period after it, when the Earth had not yet stabilized in its new position. This would be a warning to future generations, a reminder of the fragility of our world and the possibility of sudden, radical changes. This hypothesis opens up completely new horizons for understanding the astrolabe. It transforms it from a simple astronomical instrument into a chronographer, recording not only the passage of time, but also dramatic events in the history of the planet itself. And if so, then the stars on Alexander's astrolabe are not just vanished luminaries, but silent witnesses to a cosmic drama that unfolded on Earth. If the precession of the Earth's axis and even a global pole shift cannot fully explain all the anomalies of Alexander's astrolabe, then perhaps the reason lies not only in changes on Earth itself, but also in larger-scale cosmic phenomena. We are approaching the most exciting and perhaps frightening idea. The astrolabe may be an ancient warning of periodic cosmic catastrophes affecting our planet. This thought forces us to look at phantom constellations and vanished stars in a new light. What if they are not just a reflection of long-past eras, but markers in a calendar of cosmic events? Throughout human history, from ancient myths to modern scientific hypotheses, there have been mentions of periodic cosmic threats. Scientists today are actively researching these cycles, trying to find patterns in meteor showers, comet impacts, supernova explosions, and other potentially dangerous phenomena capable of fundamentally changing life on Earth. One such cycle is the so-called cosmic rain, a hypothetical period when Earth passes through regions with an increased concentration of asteroids and comets. Some researchers suggest that such periods may recur with a certain periodicity, possibly related to the movement of our solar system through galactic space. Each such passage can increase the likelihood of collisions with large cosmic bodies capable of causing global climate changes, mass extinctions, or even leading to a shift in the Earth's axis, as we discussed earlier. Comparing the astrolabe data with these alleged cycles has yielded surprising results. For example, the quote 1, which, as we found out, could have been visible around 3,000 years BC, coincides with the peak of one such hypothetical quote 2. Ancient Sumerian texts, which mention this constellation, also describe quote 3 and quote 4, which could be an interpretation of a meteorite bombardment and subsequent tsunamis. Even more intriguing was the quote 5, visible about 5,000 years ago. This period coincides with the presumed cycle of the solar system's passage through a dense region of interstellar gas and dust. Such an event could have caused not only an increase in the number of comets and asteroids, but also affected the brightness of some stars due to light absorption. The astrolabe may record not only vanished stars, but also those whose brightness temporarily changed due to cosmic clouds. Scientists have also drawn attention to mentions in various cultures of doomsday calendars or great cycles that end in global cataclysms. The Maya, Aztecs, Indian Vedas all speak of the periodic renewal of the world through destruction. And although this knowledge is often clothed in mythological form, it may be based on observations of real cosmic cycles. Perhaps Alexander's astrolabe is not just a map of the starry sky, but a kind of astronomical calendar predicting these catastrophic events. The patterns on it may not just be constellations, but symbolic markers indicating certain time intervals when Earth will again be under threat. Vanished stars may not be those that physically ceased to exist, but those that became invisible due to dense cosmic clouds, heralding the approach of danger. Or conversely, new stars that suddenly appeared in the sky could have been bright supernova explosions, whose radiation could have affected the Earth's atmosphere and climate. Modern astrophysical studies confirm that supernovae located relatively close to Earth can have a serious impact on our planet. Powerful bursts of gamma rays and cosmic particles can destroy the ozone layer, cause mutations, and even provoke climate change. If the astrolabe contains records of such events, it would be invaluable knowledge. The hypothesis of cycles of cosmic catastrophes gives Alexander's astrolabe a completely new meaning. It transforms it from a simple historical artifact into a predictive tool, created to warn future generations. If so, then the ancient masters who created this instrument were not just astronomers, but guardians of knowledge, trying to convey to us information about potential threats from space. And deciphering this message may turn out to be far more important than we could have imagined. We have already explored the mysterious stars on Alexander's astrolabe and considered hypotheses about the precession of the Earth's axis and even a global pole shift. But now it's time to ask perhaps the most uncomfortable question. When was the instrument itself created? The answer, it turns out, is full of paradoxes and contradictions that challenge all our notions of ancient history. Scientists, like detectives, tackled the case with an entire arsenal of dating methods. Each yielded its own results, but none led to a clear picture. And this, believe me, only heightened the intrigue. First, radiocarbon analysis was performed on organic residues found in the dust and microscopic fragments embedded in the astrolabe's mechanism. These particles likely entered there during the instrument's use. The results showed a very wide range of dates, from 1500 years BCE to 200 years CE. That is, a spread of 1700 years. This was too imprecise to give a specific answer, but it already pointed to the artifact's profound antiquity. Then, thermoluminescence analysis was applied, which is usually used for dating ceramics and burnt stones. It is based on measuring the accumulated energy in the crystal lattice of minerals after exposure to radiation. Of course, the astrolabe is not ceramic, but microscopic quartz particles were found in its composition that could provide valuable information. This method yielded a narrower range, but still remarkably wide, from 850 years BCE to 150 years CE. Again, centuries of uncertainty, albeit with a clear shift towards more ancient times. The most intriguing data came from the isotopic analysis of the metals from which the astrolabe is made. We have already spoken of the extraordinary purity and complexity of the alloy. Metallurgy specialists were able to determine the age of the ore from which the metal was smelted. And here the real paradoxes began. Different alloy samples pointed to different ore sources, which seemed to have been mined at different times and in different regions. One component of the alloy was dated to approximately 2,500 years BCE, while another was only about 300 years BCE. How is this possible? Was the astrolabe really made from metals extracted in different eras? Or, even more incredibly, is it the result of repair or modification carried out over millennia? These conflicting data about the instrument's age forced scientists to propose several possible explanations. Firstly, the hypothesis of a centuries-long creation history. Perhaps the astrolabe was not created at one time. It might have begun to be manufactured in one era, then it could have been lost, found, and supplemented or modified in another. This would explain the presence of metals of different ages and the wide range of dating for organic residues. Imagine, masters of one civilization create the foundation, then, millennia later, other masters, perhaps from an entirely different culture, refine it, adding new elements or improving the mechanism. This would be a unique example of technological continuity across centuries. Secondly, the existence of multiple, quote, zero. If the astrolabe was not just an instrument, but a kind of sacred object or repository of knowledge, then it could have been created or supplemented by various groups of scientists or priests over a long period. Each group could have added their knowledge and technologies, which would lead to such a complex and multi-layered structure as we observe. This could also explain the presence of different engraving styles, which were also discovered during detailed study. Thirdly, there is the hypothesis of, quote, one. This is the boldest and least scientifically substantiated explanation, but it arises when all other hypotheses reach a dead end. What if the astrolabe's material somehow interacted with certain temporal fields or energies, changing its properties? This sounds like science fiction, but in the face of such inexplicable contradictions, scientists are willing to consider even the most incredible ideas. And finally, the simplest but no less intriguing explanation. The astrolabe was intentionally aged. What if its creators, possessing incredible technologies, artificially gave it the appearance of an ancient artifact to conceal its true origin or mislead future generations? This would be a kind of message, encrypted not only in the stars, but also in the matter itself. All these paradoxes and contradictions only emphasize the uniqueness of Alexander's astrolabe. It not only questions our knowledge of ancient astronomy, but also challenges our dating methods and notions of technological development. This instrument, it seems, fits into none of our known historical eras, as if it came from another time, or even another reality. And this makes it even more valuable and mysterious. We have already explored the mysterious stars on Alexander's astrolabe and considered hypotheses about the precession of the Earth's axis and even a global pole shift. But now it's time to ask perhaps the most uncomfortable question. When was the instrument itself created? The answer, as it turns out, is full of paradoxes and contradictions that challenge all our notions of ancient history. Scientists, like detectives, tackled the case with a whole arsenal of dating methods. Each of them yielded its own results, but none led to an unambiguous picture. And this, believe me, only heightened the intrigue. First, radiocarbon analysis was performed on organic residues found in the dust and microscopic fragments stuck in the astrolabe's mechanism. These particles likely got there during the instrument's use. The results showed a very wide range of dates, from 1500 BCE to 200 CE. That is, a spread of 1700 years. This was too imprecise to give a specific answer, but it already pointed to the artifact's profound antiquity. Then, thermoluminescence analysis was applied, which is typically used for dating ceramics and burnt stones. It is based on measuring the accumulated energy in the crystal lattice of minerals after radiation exposure. Of course, the astrolabe is not ceramic, but microscopic quartz particles were found in its composition, which could provide valuable information. This method yielded a narrower range but still surprisingly wide, from 850 BCE to 150 CE. Again, centuries of uncertainty, albeit with a clear shift towards more ancient times. The most intriguing data came from the isotopic analysis of the metals from which the astrolabe is made. We have already spoken about the extraordinary purity and complexity of the alloy. Metallurgical specialists were able to determine the age of the ore from which the metal was smelted. And here the real paradoxes began. Different samples of the alloy pointed to different ore sources, which seemed to have been mined at different times and in different regions. One component of the alloy dated to approximately 2500 BCE, while another was only about 300 BCE. How is this possible? Was the astrolabe really made from metals mined in different eras? Or, even more incredibly, is it the result of repair or modification carried out over millennia? These contradictory data about the instrument's age forced scientists to put forward several possible explanations. Firstly, the hypothesis of a centuries-long history of creation. Perhaps the astrolabe was not created all at once. It might have begun to be crafted in one era. Then it could have been lost, found, and supplemented or modified in another. This would explain the presence of metals of different ages and the wide range of dates for organic residues. Masters of one civilization could have created the base, then millennia later, other masters, perhaps from a completely different culture, could have refined it, adding new elements or improving the mechanism. This would be a unique example of technological continuity across centuries. Secondly, the existence of multiple, quote, zero. If the astrolabe was not just a tool, but some sacred object or repository of knowledge, It could have been created or supplemented by various groups of scientists or priests over a long period. Each group could have added their knowledge and technologies, leading to such a complex and layered structure that we observe. This could also explain the presence of different engraving styles, which were also discovered during detailed study. Thirdly, there is the hypothesis of, quote, one. This is the boldest and least scientifically substantiated explanation, but it arises when all other hypotheses reach a dead end. What if the astrolabe's material somehow interacted with certain temporal fields or energies, changing its properties? This sounds like science fiction, but in the face of such inexplicable contradictions, scientists are willing to consider even the most incredible ideas. And finally, the simplest but no less intriguing explanation. The astrolabe was deliberately aged. What if its creators, possessing incredible technologies, artificially made it look like an ancient artifact to conceal its true origin or mislead future generations? This would be a kind of message, encrypted not only in the stars, but also in the matter itself. All these paradoxes and contradictions only emphasize the uniqueness of Alexander's astrolabe. It not only calls into question our knowledge of ancient astronomy, but also challenges our dating methods and notions of technological development. This instrument seems to fit into none of the historical eras known to us, as if it came from another time or even another reality. And this makes it even more valuable and mysterious. Now that we have grasped the full depth of these temporal paradoxes, it is time to look at the very essence of the message that may be encrypted in this amazing instrument. Now that all known dating methods for Alexander's astrolabe have led to paradoxical results, and the starry sky depicted on it stubbornly refuses to correspond to any single known epoch, we are forced to ask the most fundamental question. What if this instrument was not simply created by ancient astronomers, but by representatives of a civilization that surpassed ours in development, but then disappeared from the face of the Earth? The hypothesis of a lost, highly developed civilization, or, as it is also called, paleocontact, has always sparked heated debate. But Alexander's astrolabe, with its inexplicable technologies and a map of a non-existent sky, forces us to seriously consider this possibility. After all, if none of the cultures known to us could have created such an instrument, then who did? And why was their knowledge lost? Let's consider archaeological evidence and historical parallels that, albeit indirectly, may support this bold theory. Megalithic structures are scattered all over the world, their construction still remaining a mystery to modern science. The pyramids of Egypt and Mexico, Stonehenge, Baalbek with its incredibly heavy blocks, which, according to our understanding, could not have been moved without modern technologies. These structures demonstrate astounding astronomical knowledge and engineering skills that, it would seem, do not correspond to the level of development of the civilizations to which we attribute them. The coincidence of the location of some pyramids with celestial constellations, the incredible accuracy of their orientation to the cardinal directions, as well as the use of complex mathematical and astronomical principles, all this suggests the existence of some common source of knowledge. A historian and archaeologist studying these objects cannot help but be struck by their technological perfection. For example, the ideal fitting of blocks in Peruvian Sacsayhuaman, where it is impossible to insert even a knife blade between the stones, or the polygonal masonry capable of withstanding the strongest earthquakes. This is not just mastery, but knowledge of physics and geometry, which, according to our textbooks, should have appeared much later. Now let's draw a parallel with our astrolabe. Its metal, engraving, complex mechanism All this indicates a level of technology that is thousands of years ahead of its time. This is not an isolated case, not a random breakthrough of a single genius. Rather, it is evidence of a developed technological base that allowed for the creation of such complex devices. If we accept the hypothesis of a lost civilization, then Alexander's astrolabe becomes not just a unique artifact, but part of a much larger picture. It may be one of the few surviving pieces of evidence of the knowledge and technologies possessed by these ancient ancestors. Perhaps they were capable not only of building grandiose structures, but also of creating precise astronomical instruments capable of predicting cosmic events or recording changes in the celestial sphere caused by global cataclysms. Historical records and myths of different peoples also abound with mentions of, quote, who descended from the heavens and brought knowledge to people, of a, quote, when people lived in harmony with nature and possessed incredible abilities. Of course, these are myths. But what if there is a grain of truth at their core? What if these, quote, were representatives of that very highly developed civilization who tried to share their knowledge with younger cultures? And finally, the phenomenon of, quote, three, an abundance of finds that simply do not fit into the accepted chronology. This includes the Baghdad battery, the famous, quote, 4, and, of course, the Antikythera mechanism, which remained a mystery for many years. The list of such artifacts is constantly growing, and each of them challenges our ideas about the past. Alexander's astrolabe, with its unique characteristics and mysterious sky, fits perfectly into this series. If we put all these puzzle pieces together, megalithic structures, inexplicable technologies, mythological evidence, and out-of-place artifacts, then a picture begins to emerge. A picture of the existence of a highly developed civilization that disappeared for some reason. Perhaps it was a global cataclysm, as we discussed earlier, or some other catastrophe that wiped them off the face of the earth, leaving only scattered traces of their greatness. Alexander's astrolabe in this context becomes not just an instrument, but a message. A message from those who came before us. A message encrypted in stars that do not exist, and in technologies that we still cannot fully comprehend. It is a challenge to our arrogance and a call to rethink the entire history of mankind. Perhaps the key to solving the mystery of the astrolabe lies not only in its mechanism, but also in the search for traces of this lost civilization, which, perhaps, wanted to warn us about something very important. Now that their goal is to comprehensively study Alexander's astrolabe, using the entire arsenal of modern technologies. The first step in this large-scale research was computer modeling. Scientists created a three-dimensional digital copy of the astrolabe with incredible precision, digitizing every engraving, every detail of the mechanism. This allowed them to, quote, the instrument into virtual components without touching the original, and study its internal structure without risking damage to the priceless artifact. Then, using this model, they began to recreate the movement of all the astrolabe's elements. Computer algorithms allowed them to play out thousands of scenarios, trying to understand exactly how this complex mechanism was supposed to work. They simulated the movement of the celestial sphere in different epochs, taking into account precession, nutation, and other astronomical factors. This allowed them to test all hypotheses about what the astrolabe was supposed to show and at what point in time its readings would coincide with the real sky. But modeling is only part of the work. The next stage was spectral analysis of the materials. Using the most sensitive instruments, scientists investigated the chemical composition of the alloy from which the astrolabe was made, as well as microscopic particles stuck in its pores. This not only confirmed the extraordinary purity of the metal and the presence of rare elements, as we discussed earlier, but also determined their exact proportions. Traces of elements such as iridium and platinum were found, which are extremely rare in the Earth's crust in such a combination and purity. This further strengthened the hypothesis of highly developed technologies or even extraterrestrial origin of the material. Every element, every impurity, is a potential key to deciphering the history of the instrument's creation. For instance, the analysis of trace amounts of lead and strontium isotopes allowed for the identification of the geological regions from which the ore might have been extracted, which in turn made it possible to narrow down the search for potential creators. But perhaps the most innovative research direction has been the application of machine learning methods. This is a real breakthrough in archaeology and astronomy. Artificial intelligence specialists have developed special algorithms capable of analyzing vast amounts of data: ancient star catalogs, myth texts, geological maps, paleoclimatic reconstructions, and of course, data from the astrolabe itself. Neural networks were trained to recognize patterns and hidden relationships that the human eye might miss. For example, one neural network was trained to recognize engraving styles. It was able to determine with high accuracy that the astrolabe contains elements made using different techniques and, possibly, during different time periods. This confirmed the hypothesis of the instrument's centuries-long history of creation or modification, which we discussed. Another neural network analyzed vanished constellations. It compared them with thousands of possible star configurations, taking into account all known astronomical phenomena, and tried to find matches. Artificial intelligence was able to identify several periods in deep antiquity when these constellations could have been visible from Earth, but not in one specific time window, but in various ones, which again points to the complexity and multi-layered nature of the information embedded in the astrolabe. Moreover, machine learning methods are being used to decipher the mysterious symbols on the astrolabe. Neural networks analyze their shape, arrangement, repeating elements, comparing them with thousands of known ancient scripts and symbolic systems. There are already promising initial results indicating the presence of some complex numerological and possibly even linguistic structure. The Star Archive project is not just an attempt to study an ancient artifact. It is an attempt to rethink our past using the tools of the future. It is a bridge between millennia, allowing us at last to read the message encrypted in the stars that are not there, and perhaps to understand what those who created this amazing astrolabe were trying to tell us. This is just the beginning of the journey, but each new day brings new discoveries, bringing us closer to unraveling the greatest mystery. So we have come a long way, exploring every facet of this incredible enigma. Alexander's astrolabe is not just an ancient artifact. It is a challenge to our understanding of history, astronomy, and even the very nature of reality. We began with a shocking discovery. The instrument shows stars that are not in the modern sky. This anomaly forced us to delve into the history of astrolabes, to understand their significance to the ancient world, and to recognize the technological marvel that this particular specimen represents. Its material, engraving, and intricate mechanism are astounding, thousands of years ahead of their time. We considered the hypothesis of the astrolabe belonging to Alexander the Great, a man who not only conquered worlds, but also sought to comprehend their mysteries. Although there is no direct evidence, circumstantial clues compel us to seriously consider the great commander's role in this story. Then we confronted the heart of the enigma, the map of a non-existent sky, vanished constellations, such as Phoenix and Hero's Chariot, could not be explained by simple errors or deliberate distortions. These phantom sky patterns, mentioned in ancient Sumerian and Egyptian texts, point to something far more extensive. We attempted to explain these anomalies by the precession of the Earth's axis, a slow but constant change in our planet's orientation. But, while precession provided some answers, it could not account for all discrepancies, indicating that the astrolabe holds information not about one, but about multiple epochs. This led us to a more radical hypothesis, the theory of another Earth epoch, linked to a global cataclysm and a shift in Earth's poles. Geological and paleoclimatic data, such as findings of tropical vegetation in the Arctic or traces of glaciers at the equator, indirectly support the possibility of such catastrophic events in our planet's past. Next, we delved into astrophysical analysis, trying to understand how stars could have disappeared or appeared in the sky. Theories about supernovae, binary star systems, and cosmic clouds became part of our investigation. This prompted us to consider the cyclical nature of cosmic catastrophes that could have affected Earth, and that the astrolabe might have been a kind of astronomical calendar of these events, a warning about future threats. Then we encountered the paradoxes of dating. None of the modern methods could definitively determine the instrument's age, yielding contradictory results that pointed to centuries of creation, the involvement of multiple authors, or even deliberate aging. This only intensified the feeling that the astrolabe transcended conventional notions of ancient technologies. And finally, we considered the bold hypothesis that the astrolabe could have been created by representatives of a lost, highly advanced civilization, leaving behind not only megalithic structures, but also these enigmatic messages. The project, combining computer modeling, spectral analysis, and machine learning, is actively working today to decipher these mysteries. Every day brings new discoveries, bringing us closer to understanding what Alexander's astrolabe truly represents. But despite all these efforts, many questions remain unanswered. What is the true purpose of this instrument? Was it a warning of impending cosmic events? Or is it a chronicle of long-past catastrophes that changed the face of Earth and the starry sky? Perhaps it is a message from a civilization that wanted to transmit its knowledge to us before disappearing? Alexander's astrolabe forces us to reevaluate not only the history of astronomy, but also the entire history of humanity. It shows that ancient peoples may have possessed knowledge and technologies that we are only beginning to discover. This artifact is not just a collection of stars that do not exist. It is a silent witness to grand events that shaped our planet and its place in the universe. And perhaps it is a message from the past, intended for us, for the future. A message that urges us to be prepared for the fact that space is far more complex and dangerous than we are accustomed to thinking. It is a reminder of the fragility of our world and of the eternal thirst for knowledge that drives humanity. Unraveling the astrolabe is not the end of the journey, but merely the beginning of a new stage in our understanding of ourselves and the universe.